Welcome to Algebra, graphing quadratics from a table. The graph of a quadratic equation, such as y equals x squared, is made up of x and y values, which can be shown in a table like this, the first 5 values of this function and plotted on a graph. This function happens to be the simplest possible quadratic equation, called the parent function for quadratics. You can see the relationship between x and y values. Each y value is the square of the x value. 0 squared is 0, 1 squared as well as -1 squared are both 1, and then 4 is the square of both 2 and -2. To draw the graph, simply connect the dots in a curved manner, with the shallow slope at first and growing steeper with each value. The axis of symmetry is x equals 0, the x value of the vertex. This is the very nature of every quadratic function, a vertex at the bottom, or top, and then curving upwards or downwards on each side. Let's try another quadratic equation, y equals x squared plus 4x minus 2. First, we need to find the x value of the vertex to know where to start. We use the formula x equals negative b over 2a, replacing b with 4 and a with 1. Which evaluates to -4 over 2, and simplifies to -2, which we place in the middle row of the table, representing the x value of the vertex. Now we find the corresponding y value by using the original equation, substituting -2 into the place of x, evaluating it step by step until we find the value -6, which goes into the table next to -2, showing us the vertex -2, -6. We do the same with neighboring values in the row using x values of -3 and -1, finding the y values for those, and then -4 and 0, finishing out the 5 values to form the graph, and then connecting all the points of the parabola curve. The axis of symmetry is the line represented by the x value of the vertex, x equals -2. Let's do one that opens down. Y equals -2x squared plus 4x plus 3. Again, we find the x value using the formula x equals -b over 2a, replacing b with 4 and a with -2, which evaluates to -4 over -4, which simplifies to 1, which we place in the middle row of the table as the x value of the vertex. Now, we find the corresponding y value by using the original equation, substituting 1 into the place of x, evaluating it step by step until we find the value 5, which goes into the table next to 1, showing us the vertex 1, 5. We do the same with the neighboring values in the row, using x values of 0 and 2, finding the y values of 3 for those, and then -1 and 3, finishing out the 5 values to form the graph, and again connecting all the points in the parabola curve. The axis of symmetry is the line represented by the x value of the vertex, x equals 1.